Evenings are the beautifully sweet spot between the harsh light of the day and the dead darkness of night. Good evening to one and all present here. On behalf of PG and Research Department of Mathematics, DG Vaishnav College, I welcome all the PG students and CSIR aspirants. Prayer does so many things. It heals, comforts, strengthens, and brings you faith. Now, Tamuttai Varthu followed by college prayer.
நீராறும் கடலொடுத்த நிலமடந்து எழிலொழுகும் சீராரும் வதனமென திகழ்வரத கண்டமிழே எக்கணமும் அதிசிறந்த திராவிடனல் திருநாடும் தக்க சிறு பிறை முதலும் தரித்தனரும் திலகமுமே அத்திலக வாசனை போல் அனைத்துலகும் இன்பமுற எத்திசையும் புகழ் மணக்க இருந்த பெரும் தமிழனங்கே தமிழனங்கே உன் சீரிழமை திறம் திகழ்ந்து செயல் மறந்து வாழ்த்துதுமே வாழ்த்துதுமே வாழ்த்துதுமே.
सत्यव्रतं सत्यपरं त्रिसत्यं सत्यस्य योनिं निहितं च सत्ये सत्यस्य सत्यं ऋतसत्यनेत्रं सत्यात्मकं त्वां शरणं प्रपन्नाः वाणी गुणानुकथने श्रवणो कथायां हस्तौ च कर्मसु मनस्तव पादयोर्नः स्मृत्यां शिरस्तव निवास जगत्प्रणामे दृष्टिः सतां दर्शनेस्तु भवत्तनूनाम् नमो भगवते तस्मै कृष्णायाद्भुतकर्मणे रूपनाम विभेदेन जगत्क्रीडति यो यतः ॐ शान्ति शान्ति शान्तिः.
This is C4 workshop Chase, Crack, Conquer, CSIR Net, which will make the CSIR aspirants to go to the next level. Today, our resource person, Dr. R. Sivaraman, Associate Professor, PG and Research Department of Mathematics, DG Vaishnav College, Chennai, founder, Pi Mathematics Association. Now, I hand over the session to you, sir.
So, good evening to all. Shall I share the screen, sir?
Yes, sir. You can share now, sir.
Okay. So, is it audible to you?
Yes, sir. Audible, sir. Audible.
Thank you. Is the screen visible, sir?
Yes, sir. Yes, sir. Visible, sir. Sir, make it to slide view, sir. Yes, sir. Now, fine, sir. Sir, that hide button, sir. Okay, sir. Okay, sir.
Okay, so I welcome everyone for this 10th session of C4 CSIR net class conducted by Department of Mathematics, DG Vaishnav College. As I did in the previous class, I will be discussing problems from mainly from rail analysis and part A questions, which is mixed type, whichever I felt is very interesting to me to solve. So I hope most of you could even enjoy seeing the solution for them. So before I begin my class, I can tell you that the timing is 6 to 8 and the session is 10. I found a beautiful relationship between these three cases because 6 square plus 8 square is 10 square. They form sides of a Pythagorean triangle. So it's very apt that I like Pythagoras very much. So it's very apt that I take this 10th session on for this particular day between 6 to 8 because they form sides of a right triangle. And moreover, if you add 6, 7 and 8, 6 to 8, you get 21, today's date. So this is somewhat a little relationship that I found between the numbers, which can be related to our date and other things also. So my first problem of discussion would be, see, I have chosen questions mainly from December and June of 2019, the previous year paper. So you can see some of them, whichever I like. Some of the questions are very good, so I have chosen in that way. Beginning with some easier problem, we'll go a little by step by step. The difference between the squares of two consecutive integers is 408,235. That is 4,08,235. The sum of the numbers is, because the numbers are consecutive numbers, let us assume that the numbers are n and n plus 1. Because here numbers refers to integers here as in the question. So let the consecutive integers refers to be n and n plus 1. It is given that the difference between the squares is, that is n plus 1 the whole square minus n square. Upon simplification using a square minus b square is a minus b times a plus b. So you get 1 times this one. Incidentally, what happened in this problem was the sum of the numbers, namely n plus 1 plus n, is one of the factor here, because a square minus b square is a minus b times a plus b. A plus b is what is asked in the question, the sum of the numbers. So this is what we require. One of the factor is 1, therefore you get 2n plus 1. This is what we require. So the same answer is what is required. So the answer is option 4. So little calculation from basic algebra will lead you to the answer immediately. This is a very nice question. In fact, you can try to do similar kind of problem when you are given difference of consecutive odd numbers and consecutive odd integers or even integers and so on and so forth. That will be more interesting. So you can expect similar kind of problem. I have seen this kind of problems many times in part A in CSAR. So you can practice this kind of problems. Which one of the following numbers is a prime number? Of course, prime numbers are very special for mathematicians. Those who are very well versed in numbers and factorization process can immediately guess the answer. Now you know that if taking the first option 183, the sum of digits is 12, that is divisible by 3. If sum of digits of a number is divisible by 3, then the number itself is divisible by 3. So this number 183 is divisible by 3. In fact, 61 times 3 is 183. 121 of course is 11 square. So this nothing much to think about it. So that is not a prime number, the second option. Coming to the fourth option 10201, that is 101 square. So if you multiply 101 with 101, you get 10201. The easiest way to think of 10201 to be a composite number is that you take the nearest number, like 10,000. 10,000 is 100 square. Then you take the nearest square to this and apply the same formula here, the one that we used previously. So 101 square minus 100 square is 1 times 100 plus 101, which is 201. So difference between 101 square and 100 square is 201. Therefore 101 square is 100 square plus 201, which is 10,201. So this is one of the easiest way, or you can use that vertically and crosswise formula, Vedic math principle and all those things to guess this answer in option 4. Therefore all this, the numbers in options 1, 2 and 4 are composite numbers because they are factorizable into proper factors, and hence 157 is the answer. That is the prime number. So 157, as you can check, is the prime number among these 4 numbers. So the answer is option 3. These are all somewhat easier problems to start with. The difference, the sum and product of 2 integers are in the proportion 1:3:10. The 2 integers are. So first, to think and filter the options, if you assume that the integers are x and y, because it is given that the sum, difference and sum are in the ratio 1:3, x minus y will be k and x plus y will be 3k. So if you can add them, you get 2x is equal to 4k. So x will be 2k, which means the one of the integer x, which is larger one, should be an even number. If you say because x is 2k for some k, 2k is always even. So these 2 options are filtered out because the larger number should be even numbers. So 9 and 5 are ruled out. So the answer is either third option or the fourth option. To see which one among this is correct, you are given the next clue that the product of 2 integers are in the proportion 1:3:10. That is, if you take the difference of them, you get 5 over here. If you take the product, you get 50. So 1:10 is the proportion between the difference and the product. So here it is 5 and 50. Therefore, option 3 is correct. As you can check, option 4 won't be correct because if you take the difference of 10 and 3, you get 7, whereas the product is 30. That is not in the ratio 1:10. Therefore, the correct option is option 3. These are all very easy questions to guess. To start with, I began with somewhat easier problems to think about. In a certain cipher language, bike is coded as Y, F, H, B, and all those things. So now listen, you can apply mathematical technique, but if you're very clever enough, you can guess the answer immediately because this coding procedure is not very hard to crack. You can see that E corresponds to B. Listen, which means E is 5th alphabet and B is 2nd alphabet. So 5 goes to 2. So you have to subtract 3 letters to get this from this. E is 5th alphabet, B is 2nd alphabet. So 5 minus 3 is 2. So the idea is subtract 3 from each letter and take modulo 26 if it is below, if it is negative or something. And you can see you are asked to decode the letter scooter, and you see the letter E in scooter. E corresponds to B. So if you can see, the last but one letter is E here. So that corresponds to B because this is the only option, last but one. E corresponds to B. In bike, E corresponds to B. In scooter, E corresponds to this letter B. So that should be the option, correct option. But let us check. Let us not conclude immediately, jump to the conclusion. In scooter, if you see C over here, in scooter, you can see C here. And in car, you can see C here. So C is decoded as Z. Therefore, this C is decoded as Z. So our guess is correct that C is. So let us check. You have to subtract 3 for each letter. So S is 19th alphabet. 19 minus 3 is 16. 16th alphabet is P. Okay. 3 is 3rd alphabet. 3 minus 3 is 0. And modulo 26, that is 26. So that is Z. And if you keep on subtracting 2 from each letter, here in the word scooter, you get letters in the 3rd option. Of course, you have, if it is negative or 0, you have to take modulo 26 because English alphabet contains 26 alphabets. English language, you have 26 alphabets. Therefore, you have to take modulo 26 and to get this particular answer. So T, for example, is 20th alphabet. So subtracting 3 from it, you get 17th alphabet, that is Q. 17th alphabet is Q. So you can get all these answers here. So here R corresponds to O, here R corresponds to O. So without doubt, the answer is 3rd option. The other options are left out. So there can be little trickier things that you can do to save your time in guessing little differently, not following the direct way in many problems, especially in part A questions. Now let us do somewhat involved problem, not very easy as the earlier ones. The number of digits you have to type to write all the pages of a book starting from 1, the first page starts with 1, This total number of digits in the book is 2019 because it's asked in the 2019 paper. Okay, this is a question from 2019 December paper. So it is 2019. What is the number of pages in that book? So you see there are 9 one-digit numbers 1 to 9. You have 9 one-digit numbers 1 to 9, 90 two-digit numbers from 10 to 99, and 900 three-digit numbers from 100 to 999, and so on and so forth. So that itself is a GP, like 990, 900, 9000. So you get 9 one-digit numbers, 90 two-digit numbers, 900 three-digit numbers, 9000 four-digit numbers, 90,000 five-digit numbers, and so on and so forth. Now, first 9 pages, because book starts from page 1 with 1, the first 9 pages will contain only 9 digits, and the next 92 digit numbers will contribute, each page with 2-digit number will contribute 2 digits for each page. Like if you have page with 12, you have 2 digits in it, 1 and 2. So for the first 9 pages you have just 9 digits. From page 10 up to page 99, each page will contribute 2 digits. Therefore this 90 pages containing 2-digit numbers will contribute to 180 digits. Okay, supposing if all the 3-digit numbers are consumed, then there are totally 900 3-digit numbers. So that will contribute to 3 times, because a 3-digit number, 3 times 900 is 2700. That is more than 2019, which means the book does not contain all 3-digit number pages. Therefore I do not know how many pages of 3-digit that the book can possess. I assume that there are k pages with 3 digits. Okay, because each page contains 3 digits, the total number of digits with that many pages is 3k. So this adds up to 2019. That's the total number of digits in the book that we want to have. So solving this very easy linear equation, you get k 610. Therefore the number of digits in the book should be 9 plus 90 plus 610, adding up to 709. The third option is the correct answer. So this kind of problems are very familiar and very much asked, not only in NET exam, but in very generally in many entrance exams like TNPC Group 1 exam, or many. These are all very familiar and standard problem which are very commonly asked in not just Group Part A in CSIR, but generally all exams in UPSC, for example, or any national level exams and state level exams. These are all very, very commonly asked questions. So especially for young students, this kind of ideas will be useful. So please make a note of them. You can just do the other problems of similar kind with the same variation. Okay, if we give the idea, you can just work it out. Maybe these numbers may vary here and there, so the answers may vary accordingly. Now, if you know the properties of numbers, especially about some of the numbers, you can answer some of the questions very easily. This is one such problem. The person A tells B, I could be visiting you on any day the next 2 months, and you must give me gold coins as much total weight in grams as the number of days that would elapse from today. If gold coins are available in integer gram weights, what's the least number of coins? So there's nothing special. If you remember in my first class, I had done a similar problem with 5 kinds of ingredients forming a soup. Okay, so that is a combinatorial problem for which I gave the answer to you. Now, see, all kind of problems of this type involve powers of 2. So what I'm going to do is, you have to choose 5 objects with you, 5 grams of weights, such that 2 months is roughly 60 days or 61 days, depending upon how you choose your months. Some any way from 58 or 59 days up to 61 days, if you count February also. So anywhere between these two. And if you take powers of 2, 2 power 4 is 16, 2 power 5 is 32, 2 power 6 is 64. So 64 comes very near to 2 months period. That's a clue in this answer. So 2 power 6, so I need only 6 weights. In fact, I can explain this, and the answer is third option, 6. Because 2 power 6 is 64, that is the nearest number to 2 months period. Okay. But how does this work out? So the answer works out because if my possible weights are 1 gram, 2 gram, 4 grams, 8 grams, 16 grams, 32 grams. This is all I can have. So 1 to 32 grams. So 1 is 2 to the power 0, 2 is 2 power 1, 4 is 2 square, 8 is 2 cube, 16 is 2 power 4, and 32 is 2 power 5. 2 power 0 to 2 power 5. 6 weights I have. So if my friend comes and asks me about giving 40 grams of something, gold coins here. So what I can do is for 40, I have to choose 1 32 and 1 8. 32 plus 8 is 40. I can just give this to him. Supposing if he demands 27 units of gold coins or grams of gold coins, I can just choose 16, and because 16 is already with me there, I can choose 8 powers of 2. 16 plus 8 is 24. I can choose a 2 and a 1. So 16 plus 8 plus 2 plus 1. So with this 5 weights, namely 1, 2, 4, 8, 16 and 32, I could give any possible number between 1 and 63. That's the idea behind choosing all these numbers. Okay, because if you add 1 to 2 power 5, 1 plus 2 square up to 2 power 5, you get 2 power 6 minus 1. So that is 63. Because the answer is 63, this weights will enable me to provide any combination of numbers uniquely. The linear, again in algebra, these weights are my vectors forming the basis of numbers from 1 to 63. You have to choose a scalar accordingly. Interestingly, this representation of powers of 2 writing as a linear combination for any number is a unique way. That's the beauty in dealing with 2. You can't get unique linear combination when you deal with powers of 3 or 4 or something. So that's the beauty in dealing with 2. And that's why powers of 2 are always interesting and very important. So many problems will focus on powers of 2 like this, some way or other. So the answer is option 3, which is 6. The next question, a ball rotates at a rate small r rotations per second and simultaneously. So you can read out the question. I'm not going to read it out. So if the ball is, if there are two balls rotating in the same direction, same sense, the rotation and revolution are in the same sense. You know from basic physics that if two objects goes in the same direction, then the relative velocity is a greater velocity minus smaller velocity. If it is moving, if the objects are moving in the opposite direction, then the relative velocity is their sum. Suppose if v1 and v2 are two velocities of bodies moving in the opposite direction, then the relative velocity v1 plus v2. Whereas if they are moving the same direction, it is v1 minus v2 or v2 minus v1. In general, modulus of v1 minus v2. So this is how relative velocities are computed. This is from basic mechanics. So here you are asked to find, because the objects are moving in the same line of center and the same rotation is in the same sense. This configuration repeats after a time of one revolution. They meet at a same point. After one revolution, they meet at the same point. So for complete one revolution, the time is distance by relative velocity, speed here, distance by speed. If you assume that the distance is 1, then the answer is 1 by speed is relative velocity, capital small r minus capital R, because small r is greater than capital R. So the relative velocity is difference between the velocities. So 1 by r minus r. So with this you get the first option as the answer. The next question is very interesting for those who like geometry. The cross section along two mutually perpendicular axes of a solid object or a circle and a square respectively. The object is a truncated cone, a cylinder, a rhomboid or a cube. Now the cross section refers to cutting the object through a kind of knife or some object, where you get the resulting thing like a sheet of paper or something. Where if you cut, what section that you get, that is what is asked. Now what kind of object that you can cut to get possibly a circle and a square. Now if you cut a cone, possibly you get circle, especially if you take the axis of a cone and cut it perpendicular to the axis, you get squares, I mean circles of different radius. Whereas if you cut the cylinder perpendicular to the axis of the cylinder, you get again circles, but same size circles. In cone, you get different sizes of circles, but in cylinder, you get same size. In rhomboid and cube, you get a square, of course, if you cut a cube perpendicularly, but you don't get a circle in a cube. So I had given the answer here. So if you take a cylinder and if you cut horizontally, like perpendicular to the axis is the vertical line, central vertical line, you get a circle. And if you cut little obliquely, little angle, you get an ellipse from a cylinder. And if you cut this way vertically and open it up, you get a you see this section here, you get a rectangle or a square. You get usually a square if you choose the radius and height of the cylinder accordingly. Generally, if you cut because the idea comes because if you take a rectangular sheet of paper and fold end to end, you get a right circular cylinder. So if you open it up, you get a rectangular sheet. If you want to get a square sheet, you have to choose the radius and height of the cylinder accordingly. Then you get this. So the cross section of cylinder horizontally and vertically will produce circle and a square. Even you can sometimes have a rectangle, so there is not a problem. Whereas for a cone, if you cut vertically perpendicular to the axis, horizontally perpendicular to the axis, you get a circle. So this is true for both the cases, but the difference between cutting cylinder and cone is here you see the circles are of different sizes. As you go to the vertex, the size of the circles decrease. Whereas in cylinder, wherever you cut horizontally perpendicular to the axis, you get same circles of same size, but here the sizes diminish. Near the base, if you cut, you get a circle of larger size, but as and when you go to the vertex, if you cut, you get this smaller circle. But here it is not so, same circles. So that's the only difference. But if you cut vertically through a cone section, you get a triangle. As you can see in many problems of solids of revolution, when you take a triangle, right triangle or some particular triangle, in particular if you take a right triangle and rotate it about x-axis or y-axis, you get a right circular cone of corresponding radius and height. So the clue comes over there. So if the question was given circle and a triangle, then the answer should be a cone. Okay, so depending upon how the question is given here, the catch is in the term square. If it is given as a rectangle, people could have immediately guessed. But remember, every square is a rectangle. Okay, so there's nothing to bother here. Okay, you have to, even if it is given as square, and if you get a rectangle, you can accept it because every square is a rectangle. That's a catch over this problem because people get confused often. So these are all problems which I found was very interesting, not very straightforward, but you have to think a little bit out of the way so that you can get these answers. Not very immediate, of course. There's no particular step like doing this problem here, where you get some arithmetics to do and arrive at the answer algebraically. Here, that is not the way to do. You have to think geometrically. Graphs A and B define the same relationship between y and x for xy positive. Because xy are positive, the graphs are in the first quadrant region. Now, this is graph of maybe xy is equal to 1 or xy is equal to constant for some positive number k. Xy is equal to k for some k positive number. Because x and y are positive, therefore the product is also positive. So if you remember, this equation corresponds to one branch of rectangular hyperbola, whose other branch comes in the third quadrant here. Okay, xy is equal to c square. It's a rectangular hyperbola where one branch comes in the first quadrant, the other branch comes in the third quadrant. But we do not bother about that because we are given xy to be positive, so we just focus on the first quadrant. This is one branch of rectangular hyperbola. So if you assume that xy is 1 without loss of generality, what kind of value that I choose here? So that this is 1 here. So this is 0, this is what? This graph is 1. So this is x. So listen, y is equal to 1 by x here. Okay, so y is equal to x. xy is equal to 1. That's a graph. So y is 1 by x here. xy is equal to 1. That's a graph here. So what kind of choice that I choose here? So that the product is 1. So if you multiply these two, okay, the answer should be 1. So what kind of number that I can choose here? So possibly if I choose y is 1 by x here, so if I choose x into y and if I substitute y is 1 by x, I get x into 1 by x, that is 1, because x into y is 1 according to this equation. If you choose the other numbers, you can't get this answer because 1 by x is y need not be 1 here. So x square, if you choose, that is a parabola, so you don't get that. X by y won't work either, therefore this is the only option. If you put y is 1 by x, if you put y is 1 by x here, you get x square. That doesn't look like a straight line, that's a parabola. So if you put y is 1 by x here, you get x times 1 by x, that is because x is positive, you get 1, that represents this particular line. So this question mark should be the fourth option, xy. So little bit of application of basic ideas, and if you have some basic thing about how the graphs look like, you can answer these questions very easily. And the graph is not very difficult. You study about rectangular hyperbolas in your higher secondary second year itself in +2 class, so you have to just recall them. And this is one of very interesting question that I saw in part A paper question. So I was just picking up some of the very curious and interesting questions, not all questions, which some of the other questions are straightforward. Like if you know the methods, you can get the answer with direct form application of formulas. But this question, some of them that I'm taking here are not of that type. Which of the following figures can be drawn without lifting the pen from the paper or retracing? You cannot come back along the same line. That is what retracing. If I travel through this line, I cannot come back to the same line, and I should not lift my pen. So I cannot draw this line and lift my pen and draw this line like this. So I have to go continuously until I trace all the edges here. What we call in graph theory, these are all vertices and these are all edges. See, there is a concept of doing the same thing in graph theory called Eulerian graphs, named after the great Swiss mathematician Leonhard Euler. Now, Eulerian graph is a graph which is basically where you start at some point and travel all edges. You can repeat the vertices, but not the edges. You can travel along same vertex twice or more than once, several times in fact. And if you can come back to the same position, that is called Euler tour, and any graph containing Euler tour is called Eulerian graph. But here, Eulerian trail is a trail where you can just travel from one to other. So if I can, I need not have to end up with the same. So the question is asking about which among these two graphs has Euler trail. Trail means I can start at some point and end at some other point after tracing through all the edges. But only thing is I cannot come back the same edge that I have traveled before. So the answer lies in this case. You see here, I can come like this here, I can come like this, I can come like this, I can go like this. So here I have traveled all the edges once without retracing. I ended here. So this is the answer. You can't do it here unless you cross more than once. If I come here, I have to travel only along this line to travel this edge. This is already traveled edge. You see, we have traveled here already one. So I have come across to this. So to cover this particular edge, I have to either cross this edge or this particular edge to cover this. Therefore, here such a Euler trail is not possible, but here it is possible. And there is a classic theorem saying that, see, for getting a closed Eulerian tour, all the vertices should be of even degree. That is the degree of a vertex is number of edges passing through it. So this vertex has degree 2, this vertex has degree 1, this vertex has degree 3, this vertex has degree 4. Same thing here, degree 3, degree 1, degree 5 over here, and degree 3 over here. So you have all the 4 vertices of this graph, all are odd vertices, odd degree vertices. Here 1, 3, these 2 are odd degree vertices, whereas these 2 vertices are even degree vertices, because degree of this vertex is 2 and degree of this vertex is 4. Now there is a theorem saying that if your graph has 0 odd degree vertices or only 2 odd degree vertices, then you can have an Eulerian trail. that is a necessary condition for a graph to possess an Eulerian trail. In particular, if there is no odd degree vertices, if all the vertices are of even degree, you can start at a point and end at the same point, like a square. If you take a square, you can start at one particular vertex, go to all other edges and come back to the same point. That is not possible here. You cannot come back. If I start here, I cannot come back here in this graph. But what I can do is I can go to some other vertex after covering all the edges. In fact, the other vertex that I finally end here, if I start with odd degree vertex, should also be of odd degree. So among the two odd degree vertices, you have to start at one particular odd degree vertex. Usually that starting point should be vertex of least degree. So because this is of degree 1, I'm starting here. To take the Euler trail, I come here, I come here, I come here, I come here, I come here. Remember, we are using this particular vertex here twice. I can repeat the vertex but not the edge. So when I start coming here, this vertex is already, I have arrived here. I go here, I go here, I come back here. So this vertex is used for the second time in going here. So vertices can be repeated in Eulerian trail or path, but edges cannot be repeated. So that is the Eulerian trail and path graph. So if your graph contains exactly two odd degree vertices, there is a path. You can always choose a path covering all the edges, but the problem is you cannot come back to this position because there are two odd degree vertices. If you want to come back and close the path, you have to have the condition that all the vertices are of even degree. There should be no odd degree vertices. Okay. So, but the question is asking you to just trace every edge. They need not ask you to come back to the same position. Therefore, that is possible only here, because according to the statement, you see this vertex has degree 3, this vertex has degree 5, this vertex. So if this possibility, you can trace all the edges without lifting your pen and retracing, only if there are no odd degree vertices or exactly two odd degree vertices. That's what the theorem says. But that condition is violated here because all the 4 vertices are of odd degree here. So as I said before, if you try to make that path, you have to travel either through this edge for the second time or this edge for the second time. Unless you retrace, you can't cover all the edges because all the 4 vertices are of odd degree, and therefore the answer is first option, figure A, but not figure B. So if you know the basic graph theoretic result here, you can immediately guess this answer. It's not going to be a difficult task, but most of the students would possibly write option 4 because they were always taught in the college or in the class that Eulerian graphs or graphs which contain, see, Eulerian trail is different from Eulerian tool or Eulerian closed path. Closed path is one where you end up with all the things where you start. So you end where you start, but that is not asked here. You want to just cover all the edges once and end with some other place. The basic idea is when you start with odd degree vertex, because there's only one more odd degree vertex, you will always be ending at that odd degree vertex. If you retrace all the edges once, the final ending point will be another odd degree vertex from where you started. Okay, so you start at odd degree vertex. After retracing all the edges, you end with another odd degree vertex. You can't end here or end here. Okay, that's the idea. If you know this idea, you can use this for any particular graph. Okay, so then my next question is, the girl is running at constant speed to catch a bus which is stationary. Before she reaches the bus leaves and moves with a constant acceleration. Which one of this graph describes the situation correctly? So this is the symbol for bus, and this dash symbol is for the line segment symbol is for bus, dashed symbol is for girl. So this is speed and this is time. So listen, the girl is running at a constant speed. Because girl is running at a constant speed, constant graphs are horizontal lines. So this can't be the answer. And third and fourth option can't, because the dashed lines are representing girl, because the statement says the girl is running at constant speed. Constant functions are horizontal lines. Y is equal to 1 or y is equal to 2 or something. So answer is either the first option or the second option. It can't be third or fourth. Very first sentence rejects the third and fourth options because these are all increasing. Here the speed is increasing from 0, it is increasing. Here also the speed of the girl is increasing. But it's given that the girl is running at constant speed, so you can straight away eliminate options 3 and 4. Okay? The speed represents the y-axis here. Choose which one among these two is correct. You are given the next sentence. Before she reaches the bus leaves and moves with a constant acceleration. Because bus is moving with constant acceleration, it should increase. So the acceleration or the speed is increasing, so the bus accelerates. So either this or this, but which one would be the correct? So here at time 0, the girl's position and bus position are same, which means if this is the option, the girl is catching the bus in time. So this should be the answer, because here the girl is starting here, but bus is starting here. So the girl will miss the bus. That is what is given. Before she reaches the bus leaves. So when the girl is here, the bus is here and starts accelerating. So before she comes to this time, the bus will be moving away. So that is what is. So the answer is second option. Okay? So little application of logic that you have been learning with respect to the graphs and ideas in physics. You can, not much is mathematically involved here, but you have to just apply common sense and applying the fact that constant functions are horizontal functions, horizontal line segments. So because you're given that constant speed, either this one or this one, and you are given the clue which one among this is correct, the girl misses the bus in time. Therefore, if she is here, the bus is here. Therefore, there's a gap over here in time. Therefore, the time the bus starts when the girl comes at this position. If you see this position, the girl is here, but this has already started here. Therefore, the girl misses buses. So the correct situation is depicted in option 2. The next question: the velocity time curve of a body is given in the diagram below. So this y-axis is velocity, x-axis is time. So the velocity is increasing with 45 degree. You know that from basic coordinate geometry, if a line segment makes an angle theta with positive direction of x-axis, then the slope of the line segment is tan theta. So the slope of this particular line is tan 45, that is 1. Okay, and rate of change of velocity is acceleration by definition. So the slope of velocity is acceleration. Remember, the change in velocity is slope. See, for a function y, if the quantity is y, dy by dx is slope of the function y. So dv by dt, which is slope of this velocity, is acceleration. So I have to choose the graphs for. So this can't be the answer, because you see, from 0 to t1 time instant, the line is making velocity is making 45 degrees. So the rate change of velocity, which means acceleration, is tan 45. That should be 1. But here it is starting at 0 and it's increasing. The acceleration is increasing. But here the slope is always 1 from 0 to 1. Therefore, 0 to t1, the acceleration is always 1. So the answer is again either first option or second option, but not third or fourth, because here you see the slope is always 45 degrees from any instant from 0 to t1. Therefore, the acceleration is tan 45, which is 1, but this is not 1 here. So I can straight away discard these two options. This is not correct. But here from 0 to 1, the slope is 1. Here also the 0 to 1, the slope is 1. So which one among these two is correct? From between t1 and t2, you have horizontal line segments. So this line makes an angle 0 with x-axis. The slope is 0. Tan 0 is 0. So you see, between t1 and t2, for both of these graphs, acceleration is 0. So that won't give any clue to me in picking 1 or 2. But in t2 to t3, the third time interval, the velocity is dropping down. It is decreasing. So this is 45 with negative direction of x-axis. See, this is positive direction of x-axis. This is negative direction of x-axis. So the rate of change of acceleration is -1 here, because this is tan of -45 degree. This is with respect to negative direction of x-axis. This is to the positive direction of x-axis. So slope here is tan of -45 degrees. That is -1. This is +1 and this is -1. So it is dropping down. In t2 to t3, the acceleration decreases from this position to this position. Therefore, from t2 to t3, it is dropping down to -1, and it remains -1 in the whole interval. So this is 0, this is -1 here, and it remains in the value -1 because this is tan of -45 degrees. If this is the answer, this should be 45 degrees here. This is 45 degrees over here, then it is increasing to 1. So the acceleration should be 1 here, but it is not 1, it is -1. Therefore, answer is the second option. Now, in the next particular question, Which among the following diagram can represent the relationships between houses, offices, and building? Now, a simple clue behind looking at this problem at first instance is to guess that whether it's a house or an office, it should be a building. Whether it's a house or an office, anything such an construction should be basically a building. So I can't get this here, because if you take this case here, there's no house which is neither an office nor a building. Houses particularly, so both houses and offices are inclusive inside the building. So answer is either first option again or the second option. It can't be like this, because this portion corresponds to a house which is outside a building. That is not possible. Any house is basically a building. Okay, so answer is either first option or a second option. But again, if you take the second option here, you have office, but which is not a building. Any office is also a building, so you can't get this portion also. So any office or house is basically part of a building. So answer is first option. And this portion here corresponds to house both as well as an office, because you find certain houses having some floors, ground floor or first floor, uh, I mean, working as an office. So in a house you have an office also. In office you can have a house, so depending upon how much you have space you have, but both are inclusive inside the building. The answer is first option. You can't get the other three options. The basic idea here is to see that whether it's a house or an office, it is part of a building. It should be a building. So it should be subset of a building, not away from the building. Okay. And this question in part A, I have chosen in such a way. It's not exactly with respect to real analysis or something, because but I want to find maximum value of this function. You can see any first degree equation in x and y represents a straight line. Okay, and this is actually a problem corresponding to operations research. This is the objective function that I want to minimize here. Sorry, not maximum, minimum. So I want to minimize this in a region here, and you know from basic OR that for a given region, the feasible solution, optimal solution corresponding to a feasible region will occur only at the endpoints of the feasible region. So the endpoints, possible endpoints of the feasible region that is given to this subject to this constraints here are only 4 part. In fact, it forms a rectangle. So you have 0 to 10 in the horizontal line and 0 to 5 in the vertical line. So you have a rectangle with length 10 units and breadth 5 units here. So that is the object, that is the shape of the objective, this constraints that is given for this particular objective function. So there's no need to work out with anything. What you have to do, just take the vertices x0, y0. So because if at all the optimal solution occurs, it will occur only at the endpoints or the vertices of the polygon. Okay, so 0, 0, 0, 5, 10, 0, and 10, 5. So those are the possible 4 vertices of the rectangular portion that you get upon drawing this region. And if you substitute this value, say x0, y0 here, you get plus 10. If you substitute x0, y5, you get minus 25 plus 10, minus 15. So the first thing you get plus 10 here, minus 15. If you substitute 10 comma 0, you get 40 plus 10, 50. If you substitute 10 comma 5, you get 40 minus 25. That is plus 15 plus 10, 25. So among these 4 choices, upon substituting this, you get minimum value of minus 15 occurring. So I can just check you here. If you put 0 comma 5 here, you get minus 25 plus 10 minus 15 occurring at 0 comma 5. So the answer is 4th option. That is all you have to do. So this is one of very good question that I saw in I think December paper last year. Consider a location on the earth where the sun is overhead at noon. The sun is overhead at noon. Please pardon me for this horrible diagram, because I'm very bad at drawing diagrams. So if it's not looking to the scale, please adjust with it. The idea is important. Consider a location on the earth where the sun is overhead at noon. So this is a noon question where sun is exactly overhead. So this I assume is sun. Okay, if it's not looking like a sun, please forgive me. Compared to shadow at 10 a.m. So this is 10 a.m. here. See, 10 a.m. is before noon. Okay, I consider this as C is the point representing 10 a.m. 10 a.m., the shadow of the tower at 4 p.m. See, I have a tower here. When the sun is at 10 a.m., the shadow is somewhere here. The shadow will be X of the tower. Whereas at 4 p.m. in the evening, after 6 hours, okay, the same tower is having this shadow here. I was asked that at 4 p.m. the tower of the length of the shadow of the tower is twice longer, thrice longer, 4 times longer, 8 times longer, whichever it is. You can see from the basic diagram itself that when the time goes away, the shadow becomes larger, isn't it? When the time increases, when the sun moves away from noon, the length of the shadow becomes larger. But how much longer is the question here? Is it twice large or thrice large or 4 times large or 8 times large, whatever it is. That is what we need to find here. But the basic fact, there's nothing else is given here, so we need to make out the angles ourselves here. So for a full rotation in a circle around a point, you get 360 degrees, and a day contains 24 hours. So every hour the sun will move, basically. So the 24 hours for 360 degrees. So for 1 hour, 360 degrees by 24, that is 15 degrees. So for 1 hour, the sun travels 15 degrees from east to west. It goes just like this anti-clockwise direction. So at 10 a.m., from this position, it could have traveled. So for at 10 a.m., it is somewhere here, to noon, 2 hours time, it could have traveled. For 1 hour, the sun's movement is 15 degrees. For 2 hours, it is 30 degrees. Because this is 30, this should be 60. Because this is a vertical line, this is a horizontal line. From 10 a.m., so for 1 hour, the sun moves 15 degrees. Because again, I repeat, each hour, the sun moves 15 degrees. So 24 into 15 is 360 degrees, which is total angle around a point, this point. So from 10 a.m. to 12 noon, the sun could have traveled 15 plus 15, 30 degrees here. Because this is 30, this should be 60. And from noon to 4 p.m., there are 4 hours. In 4 hours, 1 hour is 15 degrees. So 4 into 15, that is 60 degrees over here. It could have come this position. And therefore, this is 30. Okay. So this portion you have at 10 a.m. you get 60 degrees, and at 4 p.m. you get 30 degrees. So this is all I have to guess from the rotation of the sun and the timing given accordingly. So if you treat, height of the tower never varies when the sun travels from along this time, because building or tower remains the same height in any point of time of the day. So if this is h, this is also h. I want to find the relationship between x and y, the shadows casted by the sun's movement of the tower. Okay. So tan theta is opposite by adjacent. So tan 60 is h by x. So that gives you h is root 3 times x. And for this right triangle in the left hand side here, h by y is tan 30. So which is 1 by root 3. So h is y by root 3. So if equating these two, because both represents h, therefore root 3x is y by root 3, giving you y is 3x. Therefore this length of shadow y is 3 times this length. So the answer is second option, 3 times longer. So some of the problems, when you see at the first instance, seem to be very vague and very lesser information, little information is provided. But when you work out the details precisely, or with some common sense, with some basic geometry or basic arithmetic or basic algebra, or whatever basic thing that you have been known in schools and other classes, you could have get the answer immediately. So little application of your mind will fetch you the answer correctly. Okay, so that is where you need some training. This problem again is one of very beautiful problem that I like. In fact, it took little bit of time for me. I couldn't guess this answer immediately when I saw this for the first time. Like this problem I guessed immediately, but I have to work it out anyway. I can't guess the answer immediately, but I have to work a little calculation and then I arrived. But I got no clue absolutely when I saw this problem. I was thinking for quite a long time, and then I got up today morning. I was thinking all the while. Then I got an idea. I was studying about all those ideas there in physics, and then I got a clue to find this answer. That is how I solved this problem. Okay, that's what the reason why I'm sharing this problem with you. balls are being rolled out with equal initial speeds along a frictionless undulating wave-like track. The undulating track is a smooth track. You don't get sharp edges here and there. It's a very smooth track with same kind of bends. In mathematical language, the curvature in along this maximum and minimum points are same. In a way, the function is differentiable function because it's a smooth function. You don't get rough path here and there. Okay. In quick succession, there is denser clustering of balls. So this is the clue behind the problem. There is denser clustering, means grouping of balls around point B than around point A. But we have no clue where B and A are. That's the question actually. Which of the following statements is true? Point A is higher than B, point B is higher than A, points A, B are of same height, and balls reached at point A first and then B, and all those variations are given. So our aim is to pick the option which satisfies this condition and location of namely the balls A and B. How do we do that? So with the given condition, I have drawn those graphs. The crests are points where you get maximum values, the upper portion. So these are all points representing what is called crest. That is, in mathematical language, they are maximum points for us. Okay, this is point of maximum. This is the maximum value. So the maximum value points are along the curve. It's called the crest, and minimum value points is along the curve called troughs. Okay. So this is in physics language. So in mathematical language, this is minimum value point, and this is maximum value. Okay. So this is another term that you can use here. See, most of the engineers apply the same ideas in mathematics through different languages. Okay, that is all. So you have to, if you know this connection, it's easy to compare them and analyze. Okay. Now, the main clue is here. There is denser clustering of balls around the point B than around point A. If this is the main vital clue with the question, apart from identifying crest and trough. Okay. Now, if the balls are traveling with equal initial speeds, you see at the maximum point, the velocity becomes very minimum. And if it comes out, the balls travels down very quickly because of the help of gravity, and it moves away. The velocity, the speed of the ball will be coming lesser and lesser. At this point, you get maximum velocity. At this point, you get minimum velocity. Okay, you get very minimum velocity here. At this point, you get, because the ball flies very quickly here, very fastly, and then it loses the speed gradually. The speed becomes zero here, and then it starts increasing its velocity, coming down, getting to maximum velocity here. Then it goes away. So this process gets repeated. Okay, of course. Due to air resistance and friction and due to various other factors, you can't find a ball which travels along wave pattern continuously for all time. That is not possible, however smooth the path is. Okay, but just for the sake of understanding. Now listen, the ball travels like this here. What will happen? So this, as I told you, at the crest you have minimum velocity. In fact, almost very minimum velocity. Here you get maximum velocity. Okay. So at the minimum velocity, the denser, you see, there is denser clustering of balls around point B. When the velocity is minimum, the points will group more. Whereas when the velocity is maximum, the balls will push out easily, immediately pushing out. If you open a tap and if you see the water flowing inside the drainage, you see when the maximum speed, the water drain very quickly. Whereas when the speed is less, it will drain very slowly. So similar to that, you see when the velocity is minimum, the clustering will be more. When the velocity is maximum, the clustering will be less, because the balls will immediately push here. It will come here and immediately go. There's no clustering, not much clustering here. But there is an accumulation of many balls here with minimum velocity here. Therefore, the answer is option 2, because you get maximum denser clustering of balls around point B. Therefore, point B should be at the crest and point A should be at the trough on its path. Therefore, crest lies above the trough. Therefore, point B is at the crest and point A is at the trough. Hence, the answer is second option. Point B is higher than point A. So these are all not straightforward questions, but if you little bit apply the ideas that you have been known, then you can get this answer very easily. So this kind of problems are not done mathematically, absolutely mathematically, but little bit of ideas will help you to get these answers. Now let me do some problems with respect to our domain, like whatever I was thinking of doing in real analysis. Some of the problems I discussed will involve little analysis and little bit of number theory and something like that, geometry and all those things. But now we concentrate problems. These are all part A questions until what I did now or part A questions. Now we'll see single option part B questions. And as I told you, all the problems that I have been showing today in this particular class are taken from either December 2019 paper or June 2019 paper in respective parts, either part A or part B or part C. So all the problems that I did were asked in part A of either December 2019 or June 2019 paper. They contain very interesting problems as you have seen now. Now, let us take this problem. Now we will take problems related to main real analysis questions. Let xn n1 to infinity be a sequence of non-negative real numbers, either 0 or positive numbers. Okay. Then which of the following is true? Limit of infimum of xn is 0 implies limit of xn. Of course, if the question is option is given limit, if limit of xn is 0, the limit of xn square is also 0, because you know limit of xn square is limit of xn times limit of xn, because limit of sn into tn is limit of sn into limit of tn. So limit of the product is product of the limit, but it is given infimum. So this is where the catch is here. So because it is given as infimum of xn is 0, I need not get this condition here. In fact, to see that I have given an example here. You see xn is 0, 1, 0, 2, 0, 3, 0, 4, 0, 5. This is a non-negative sequence because the terms are either 0 or positive. Okay. So as the question says, xn should be sequence of non-negative real numbers. In particular, I'm choosing xn to be this kind of sequence, which are non-negative real numbers. I should take example only of this sort. I can't take negative numbers here. Only then it will work. Okay. I have to verify these conditions. I can't take an example of a sequence which contain negative number, because in the statement it is very clearly given that xn is a sequence of non-negative real numbers. So if at all I try to provide an example, I should focus only on this given condition. I can't take examples of other sorts. Now, infimum of xn is 0. Clearly, you can see infimum of xn, which is if you start here from first element, infimum is 0. From second element, infimum is 0. Because zeros are taken at alternate positions here. Infimum of xn is 0. So limit of infimum of xn is always 0. So that condition is automatically satisfied. But if you square this sequence, you get 0, 1, 0, 4, 0, 9, 0, 16, 0, 25 and all those things. I would advise students to just write down in your notebook if you have your paper and pen with you. Just work out whatever I'm saying, so that that's the reason why I have not written almost all the steps. So you have to just think about yourself and keep writing so that you can verify whatever I'm saying is correct. Okay, because sometimes I may slip here and there without knowing, without my knowledge. So if there is some error, you have to just stop it. So xn square is 0, 1, 0, 4, 0, 9, 0, 16, 0, 25 and all those things. And you see that particular sequence, I'm not taking infimum here for xn square. So if xn square is 0, 1, 0, 4, 0, 4, it's an oscillating sequence. It's an infinite oscillating sequence. So that is not convergent. Therefore, limit of xn square is not 0, but limit of xn is 0. So the first option is not correct. Okay. And here, if you limit of infimum of xn is 0, but xn is bounded, that is also not possible. The same example will prove the third option is also incorrect, because xn is not bounded here. You see 0, 1, 0, 2, 0, 3, the even position terms are increasing, so it's not bounded either. Okay. So what about this? Supremum of xn is 0 implies limit of xn square is 0. For that, of course, you have to take a little example there. But if supremum of xn is 0, the limit of xn square will also be 0. I will come to that later. Taking the fourth option, if you take xn, limit of infimum of xn square greater than 4. If you take xn square here, you get 9, 9. This is a constant sequence, so it's easy to discuss. Xn square is 9, 9, 9. Every element is 9 in xn square, every term of the sequence. So limit of infimum of xn square is 9, that is greater than 4. But limit of supremum of xn. What is limit of supremum of xn? Here every element is 3 here. So supremum of xn is also 3. That is not greater than 4. Though infimum of xn square is greater than 4, namely 9, supremum of xn is 3. That is not greater than 4. So this second example disproves the option 4. So option 4 is incorrect. Options 1 and 3 are also incorrect because of this example. Therefore, the correct answer is option 2. If in fact if supremum of xn is 0, then limit of xn becomes 0. And if, as I told before, if limit of xn is 0, then because of the fact that limit of xn is always a number between supremum, infimum and supremum. See, if limit of xn is a number L, then L is always between infimum and supremum. Limit infimum of xn will be less than or equal to L, and L is less than or equal to limit supremum. Okay. So if limit of supremum is 0, the limit of xn is 0 because it's non-negative sequence of real numbers. Therefore, limit of xn is 0. Therefore, limit of xn square is also 0 because limit of xn square is limit of xn times limit of xn, that is product of 0 and 0, which is 0. So, of course, obviously, if you know that options 1, 3, and 4 are wrong, there's no need to even check whether this is correct. That is the only option left out. So, the second option is correct, but I gave the reason also for why the second option is correct. Okay. So that proves the second option is correct. What is the sum of the following series? 1 by 2 times 3, 1 by 2 square times 3. So this is an infinite series problem, usually dealt in first year UG classes, a similar kind of problem. Now the geometric series, listen, r power n, like r plus r square plus r cube up to infinity, is r by 1 minus r whenever r is a number between -1 to +1. You can see. So this is sum of geometric series. I'm not beginning with 1 but beginning with r. Okay, for a purpose here. Usually geometric series begins with 1 plus r square. In that case, the answer is 1 by 1 minus r because I begin with r here, the second term. So the answer is r by 1 minus r. This is true for any real number r between -1 to +1. Okay. Now listen, if you take the first terms in the bracket, this is 1 by 6, this is 2 square into 3 square is 6 square. Because powers are same, I can multiply them. So this is 1 by 6, this is 1 by 6 square, this is 1 by 6 power n. So group all the first two terms together in the summation. I get 1 by 6 power n, n1 to infinity. Because this is 1 by 6 power 1, this is 1 by 6 square. The summation starts from 1 to infinity. Plus I take a half outside in the second term. I group the second terms and I remove a half outside. I take a half outside. If I take a half 2 here, then this will be 1 2 and 1 3, that is 1 by 6. If I take a 2 here, you get 2 square into 3 square, that is 6 square. If I take a 2 here, you get 1 by 2 into 2 power n into 3 power n, that is 6 power n. So the second term I can group as 1 by 2. If I remove 1 by 2 outside, what I get is the same term here, the same term like this. Now this is for the form r power n, n1 to infinity. The answer is r by 1 minus r. So this is 1 by 6 by 1 minus 1 by 6 plus half times 1 by 6 by 1 minus 1 by 6. So that adds up to, this is 1 by 5, half times 1 by 5, which is 1 by 10. So this simplifies to 3 by 10. The second option is the correct answer. So this is not very much involved in it, straightforward question. You have to just know the arithmetic behind it and the application of the geometric series. Okay. Remember, geometric series is valid only when the common ratio r is a real number between -1 to +1. Otherwise, it is not possible to apply. Here the ratio is 1 by 6, which lies between -1 to +1, and therefore I can apply this formula. In the case when the ratio is more than 1 or less than -1 or something, or even 1, I can't apply this formula. Okay. So you have to be careful in choosing this, because many formulas in analysis and integrals and calculus have some basic restrictions. Only upon those restrictions you can apply them. If you go beyond those restrictions and apply the formula, you always end up with an absurd answer or unexpected answer. Let X subset of R be an infinite, countable, bounded subset. So it's an infinite set, countable set, bounded subset of R. So all the three conditions. X is infinite set, countable set, bounded subset of R. Which of the following statements is true? X cannot be compact. You remember in R, with respect to set of real numbers, compact sets are closed and bounded. Any set which is closed and bounded in R is compact. But in general metric spaces, it is not so. There are general metric spaces where compactness is different from closed and bounded. Okay, so you have to be careful in doing that. But in the Euclidean space, like R or R2 or R3 and R power n, in usual Euclidean space, compactness will be equal to closed and bounded. But in more general space like L2 space, L infinity, or general metric spaces that you can consider very special metric spaces, there are compact sets which are, sets which are, bounded but not closed, but still being compact. So compactness is very different from closed and bounded. So you have to look at those concepts very well. Okay, but with respect to R, there's nothing much different. Similarly, if when you take set of real numbers, every convergent sequence is a Cauchy sequence, and every Cauchy sequence is a convergent sequence. Both ways it is true with respect to real numbers. But for general metric spaces, in general metric space, every convergent sequence is a Cauchy sequence, but not all Cauchy sequences are convergent. So you have to be very careful in knowing which theorem works where. With respect to some spaces, it works both ways, but in other spaces, it may not be true. So you have to know these restrictions also before applying a property. Okay. So with respect to R, of course, compactness is closed and bounded, so there's no problem. So X cannot be compact. So I have to choose an X which contains all these three, satisfies all these three conditions. Like it's an infinite set. I choose this way: 1/2, 1/3, 1/4, etc. This is an infinite set. I have this doesn't contain zero because it approaches to zero. In fact, for this collection, zero is the accumulation point or limit point. So, but I'm attaching zero here. Zero is not an element of this particular set, the first set, but I'm adjoining zero with that for a purpose. Okay. Countable set, of course, this is countable. Okay. Bounded, it is between 0 and 1. All the elements are between 0 and 1. So it satisfies all the three requirements, my set X. You see, this is bounded, as you can see, closed, and the set is closed, and it is bounded because every number is between 0 and 1. It can't go beyond 0 and 1. Okay, so it is compact. So the first option is not correct because first option says X cannot be compact, but I have given an example where X is compact. It is closed and bounded. X contains an interior point. See, in a set that you take, interior point is a point where if you draw an open ball, the whole open ball should lie inside the set. Now, if you take 1.5 here, distance between 1.5 is 0.5 units. As you can see, 1 is here, half is here to the left side of 1. If I draw an open ball of radius say 0.25, about half, it will be like 1 by open interval 1/4, 3/4. That is not inside the set because between half and 1 there is no point in the set X. So open ball drawn at half of radius 1/4 will contain only half, but no other point in X. But if you say some point is an interior point, the ball drawn at that point should be entirely contained in the set X, and so that is not possible here. So half is not an interior point. 1/3. In fact, these are all points in analysis what we call adherent points, but not accumulation points. Okay, so these are all isolated points here, and therefore it contains an interior point is mistake because none of the points is an interior point here. They are just adherent point but not accumulation. X may be closed is correct because this set is closed. See, if I do not adjoin this 0, the element 0 here, then it may not be closed because if I just take the first set here, the accumulation point of this set is 0 and 0 is not in the set. A closed set is the one which contains all its accumulation points. So that is the reason I adjoined the 0 to make the option 3 is good. In fact, I can see that this collection does not satisfy 1, 2, and 4. Therefore, the answer is only the third option. That is only left option. Closure of X is countable. For this particular example, of course, I have taking this particular example, not this one. This works for the first 3 cases, but not the fourth. For the fourth option, I take X to be set of all rational numbers in the interval 0, 1. See, Q intersection 0, 1. You consider set of all rational numbers in the interval 0, 1. You know the set of all rational numbers is countable. Therefore, set of all rational numbers in 0, 1, closed interval 0, 1 is also countable, and it's an infinite set naturally. And rationals in 0, 1 is bounded because the whole interval itself is bounded. and therefore this particular x will satisfy all the requirements here. If you take closure of x, q closure is r, and this being closed, its closure is itself. Therefore, if you take closure of this particular set, you get r intersection itself, which is 0 comma 1, and you know that 0 comma 1, this closed interval, is an uncountable set. Any closed interval of finite length or positive length is uncountable. Okay, so of course singleton sets in R are closed intervals also, but the length is 0 singleton set. So any closed interval of positive length will be uncountable in R, and therefore the option 4 is not correct. Closure of X is uncountable set here, but it is given closure of X is countable. So we are left with only option 3. So this particular set X may be, it given may be cleverly, because if I leave the 0 here, it may not be closed. So that is why you can make X closed by adding its accumulation point. Okay, so that's the idea. X may be closed depending upon how you add the element. If I delete this element 0, it will not. It is not closed then. Okay, that's the purpose of adjoining 0 to the in the first example. Okay, here. And this problem also goes very lengthy actually. If I work it out, it goes to nearly 1 page of full length paper, A4 sheet. I do not know how the people were asking this kind of larger and lengthy problem. So I'm not going to explain the whole steps here, but I give the glimpse of how to do here so that you can work out the details in much leisurely. But I give the idea to you. Let less than or equal to be usual order on the field R of real number defined in relation on R2 by AB is related to C comma D. See, you cannot compare two ordered pairs, isn't it? But here we are giving order relation here. We are defining with the definition. AB is related to CD if the ordering is not possible for numbers in R2 or R3 or higher dimensional number sets. Okay. This relation that we define here is such that if the first coordinate is either less than the first coordinate here, A is less than C, or the first coordinates may be equal, but second coordinates are less than, satisfy less than or equal to condition. So either if the first coordinate is less than second, the first coordinate here, the first coordinate of the first point is less than the first coordinate second point, that's well and good. If this will be related to this, I can treat this point to be less than or equal to this point. Or the first coordinates happen to be equal, then compare the second coordinates of both the points. So if B is less than or equal to D, then first point is less than or equal to second point. This is how it is defined. And consider the subset E, which is 1 by n, open interval 1 by n, comma 1 minus 1 by n, because it's an ordered pair, belongs to R2 when n is a natural number. Okay, so E, according to the question that we have given here, when you substitute n as 1 here, you get 1 by 1, 1. 1 minus 1 by 1. This is 1 minus 1, 0. So you get 1 comma 0. To substitute n is 2, you get half. 1 minus 1 by 2 is half. So 1 by 2 and 1 by 3 and all those things. If you substitute consecutive values of n here, you get this points. Now if I see all this first coordinates here, you see this is 1, this is half, this is 1 by 3. So the first coordinates keeps on decreasing 1 because this is 1 by n. 1 by n decreases as n increases, isn't it? The first coordinate. Whereas the second coordinate forms increasing sequence. 0, half, 2/3, 3 by 4. So this increases to 1. Okay, beginning from 0. This decreases to 0 beginning with 1. So 1 half. So if the first coordinate of one point is less than the second coordinate, the first number is less, first point is less than or equal to second point. In that sense, this point is less than or equal to this point because half is less than 1. Similarly, 1 by 3 is less than 1 by 2. Therefore, this point is less than or equal to this point. Similarly, 1 by 4 is less than 1 by 3. Therefore, this point is less than or equal to this point. So if you keep on going this, naturally, the infimum of E contains a number of the form 1 by n, comma this, where n is very large, n tends to infinity. So that is 0, comma 1. So infimum of E is 0, comma 1. Okay. So that is say so this answer is not correct. Okay. In both infimum supremum does not exist. Infimum will exist. In fact, infimum of E is 0, comma 1. So that gives me only two options possibly. One is this or other one is this. Okay. And if you take supremum, see either A is less than C, that is satisfied here with respect to the first coordinate. In fact, for all the points, but I can't get supremum here because you see for all the points, this condition is already satisfied. And none of the first coordinates are equal here. So the second point is always less than or equal to first point. The third point is always less than or equal to second point. So only you can talk about infimum. You can't talk about supremum. So the answer is third option. Infimum of E is 0, 1, but supremum does not exist. Okay. So this is an example where you construct a set where infimum exists but supremum does not exist. So this kind of examples are quite unusual because we don't discuss usually this kind of examples in the class level teaching. This is another very good problem. Which of the following sets is uncountable? Set of all x belonging to R such that log x is equal to p by q for some two natural numbers p, q. Okay, so if you look at this options here, I want to find what kind of x here will satisfy this condition. Okay, so if we take log x is equal to p by q, then x is e power p by q. For any, remember p and q are natural numbers, and this p by q is a rational number because pq, in fact, p by q is a positive rational number here because pq are natural numbers here. So you can actually find a one-to-one correspondence between numbers of e form e power p by q to p by q. So what you have to do is take f of x is e power p by q going to p by q. So define a function like that, e power p by 2 to log of uh, uh, so if you take log x, for example, f of x is log x, then image of e power p by q under log is p by q. You get this answer here. So there is a one-to-one correspondence between in terms of log x between this values of x and the form p by q, where p by q is a positive rational, and you know the set of all rationals themselves are countable. Therefore set of positive rationals are subset of set of whole rational numbers. That is also any subset of countable set is countable. Therefore set of positive rationals is countable. Therefore this collection S1 is precisely is with one correspondent with set of positive rational numbers, which is q plus. Okay, this is in one correspondence between set of positive rational numbers, which is countable. Therefore this is also countable. Therefore the first example is a set which is countable. I want to pick a set which is uncountable. Okay, if you take second example here, I'm going to take the third example. X belongs to R such that x is equal to log of p by q. If x is log of p by q, then e to the power x is p by q. Again, there is a one correspondent between this relation in the terms of this equation that we can form. So this is also identical to set of positive rational numbers. This being countable, this is also countable. In terms of S4, again I get a one. I will explain with the graph also little later. I mean the next slide. But if you take S2, see this relation cos power nx plus sin power nx is 1 for some n. In fact, this is true if n is 2 because you know that cos square x plus sin square x is 1. So in particular, because it is given for some n, I'm choosing small n is 2. By choosing small n is 2, which is a natural number, you find that cos square x plus sin square x is 1, and that relation cos square x plus sin square x is 1 is true not only for rational numbers, for any real number. So for any real number x, you have cos square x plus sin square x is 1. Therefore, this corresponds to S2 corresponds to the whole real numbers, and if you take set of all real numbers, that is uncountable. Therefore, among these four choices, the second option, this particular set is set of all real numbers, and set of all real numbers is known to be uncountable. That's a very classic proof that you could have studied in your UG classes. Set of all real numbers is uncountable. Therefore, the answer is second option. In fact, to understand a little bit more clearly than this one correspondence, I have drawn a graph here. So you see in the first case, log x is p by q. So this is graph of log x. So if you give me rational number 2, I can choose this point. If you give me rational number 2.5, I can choose this point. If you give me rational number 3, I can give this point. If you give me rational number 3.25 somewhere here, I can choose this particular point here. So for every positive rational, I can find a corresponding image in log x, and log x is a continuous and increasing function, so there's no problem in getting the one correspondence, and therefore that particular set will be countable. Same thing for the other cases also. This is e to the power x because you see e power p by q, e power x is p by q. So there is a one correspondence between a positive rational like p by q, positive rational number, and e power x. So for any point here, I can obviously choose one particular image because it's a monotonic function, it's an increasing function. For any point, there is corresponds only one point here. It's not a so if it's a monotonic function, it's increasing or decreasing function. For any point, you get only one particular image because it's a one function. Okay, so there's no problem. So you can establish a bijection between them. For this cos x is equal to p by q, this graph, this is for any positive rational number, you can associate a corresponding number here. It might be negative or positive, that it doesn't matter, but you can always establish a number. But the values gets repeated here. That is not an issue for us. Okay, instead if the repetition occurs, you put only once. So this is also countable. Whereas as I said here, it constitutes the whole number. In fact, sin square x plus cos square x, if you draw the graph, you get 1. This is graph of sin square x plus cos square x. You see 1 here. It is always 1 for all x. So for any real number, sin square x plus cos square x is always 1. Therefore, that constitutes a whole real number, which is uncountable. Now coming to the next question, let f from R to R be continuous and 1-1 function. Then which of the following is true? See, this kind of trickier question needs some time to think. Don't get enthusiastic and commit common errors. Most often students become enthusiastic when they see the word continuous, differentiable, onto 1-1 and all those things. You have to think more than twice before deciding to choose the correct option. You have to think at least with 2 or 3 examples. Don't just conclude with one simple example. That is not going to help you. Okay, it will often lead you to the wrong answers. So let f be a continuous and 1-1 function, then which of the following is true? So if I take e to the power of x, okay, because my function is from R to R, you get e power x. I have chosen this particular function. There are many continuous functions, like any polynomial function is a continuous function, but a polynomial function, some of them are not 1-1. Like for example, like x square, if you take from R to R, it is not a 1-1 function. Okay, so to assure that my function is a 1-1 function, I have chosen, because it's from R to R, I have chosen e to the power of x, which is in fact continuous function and 1-1 function, because e power x is equal to f of x is equal to f of y implies e power x is equal to e power y. That implies x is equal to y. So it's easy to check that f is 1-1. And you can also see, I told you in the previous class that a function will be 1-1. So this is e power x. If you draw any horizontal line, and if it intersects the graph exactly at one point, that's 1-1. So if you draw any horizontal line in the domain of e power x, this is e power x graph, you get only one part of intersection with the graph. Therefore, that makes it 1-1. Okay, easy to see, but you have to sure enough about the graph of the corresponding function that you draw to check this. This is called horizontal line test. Okay. Okay. So this function satisfies continuity and 1-1 condition. Is it onto? It is not onto, because the codomain, if it is onto, then range of R, range of f should be the whole real numbers. But you see, e power x is always positive. As you can see, it can't even touch 0. So there's no pre-image for any negative numbers. E power x is always greater than 0. So 0 or any negative number doesn't come in the range of f. So the range of f is open interval 0, infinity for e power x. That is proper subset of the codomain R. So the range of f is a proper, if the range of a function is proper subset of the codomain, the function will not be onto. It is just an into function. So this particular function is not onto. So the first option is not correct. F is either strictly decreasing or strictly increasing. Let us come to that later. There exists x belongs to R such that f of x is 1. So I told you that e power x is positive, therefore 1 plus e power x is greater than 1 plus 0, because e power x is greater than 0. And so 1 plus e power x is greater than 1. So for this particular function, I can't find any x for which f of x is equal to 1. For all x, this is greater than 1. So third option is also incorrect. You can guess this if you know this first answer. I mean, if you choose a function for the first option, immediately extend that to the third option. F is unbounded. This is a trickier part. Okay, so for this I take 1 by 1 plus e power x. This function will always lies between 0 to 1. The reason, because listen, of course 1 is positive, e power x plus 1 is also greater than 1, so it is also positive. If you divide two positive numbers, you get the answer as positive. So that's not a, so lower bound 0 is easily obtained, because numerator is positive, denominator is positive. If you divide two positive numbers, the answer is positive. And it's less than 1 because e power x is greater than 1. If a number is greater than 1, the reciprocal is less than 1. So f of x is clearly a number between 0 to 1. To ensure that this is correct, this is the graph of 1 by 1 plus e power x. See, the lines y is equal to 0 and y is equal to 1 are asymptotes on either sides of x axis. It goes very near to 1 here and it goes very near to 0 here. So these two lines are asymptotes on either side of x-axis. So it's always it's a continuous 1 1 function. Also, it is a 1 1 function. It is bounded between 0 and 1. So it never go beyond 0 and 1. So unbounded is incorrect. F is unbounded is incorrect. Therefore, we are left with only this option. In fact, it is true that for any continuous function which is 1 1, you see, so either it's an increasing function, like this is log x, or this is e power x. If it is e power minus x, it's a continuous function, 1 1 function, but it's decreasing function. So either it's an increasing function or it's a decreasing function. We call such function as monotonic function. In fact, a beautiful property of monotonic functions are usually continuous and 1 1. Any monotonic function defined on an interval, which is well defined on an interval, is either usually a strictly decreasing or strictly increasing monotonic function will be continuous as well as 1 1. Okay, so that's one of the characterization of monotonic function. Okay, that's why when we define Riemann-Stieltjes integral or Lebesgue integral or any such thing, we usually consider for this purpose, especially Lebesgue integral, we consider monotonically increasing function. Now, consider a sequence an. This is the question. The next question is simply arithmetic, not much involved. An is minus 1 power n into half minus 1 by n. Let Bn is defined as summation ak k1 to n. That is, Bn is a1 plus a2 up to an. If we expand this, Bn is sum of n terms of an. B1 is a1, B2 is a1 plus a2, B3 is a1 plus a2 plus a3. In general, Bn is sum of nth term, first n terms of a. Okay, you are asked to pick the choices with respect to the sequence Bn. Okay, now let us compute. It's not straightforward. You can't guess it immediately. B1 by definition is a1 according to this equation. And a1, if you substitute 1 here, you get minus 1 power 1 into half minus 1, which is 1 minus half. B2 is B1 plus A2. See, A1 is B1, isn't it? So to get B2, I should add A1 plus A2, A1 and A2, but A1 is equal to B1. B1 I already know here. And if you compute A2, to substitute 2 here, you get half minus half, that is 0. For A2, this factor is 0. Therefore, A2 becomes 0. So it is same as B2, same as B1. B2 is 1 minus half. If you substitute n is 3 here, you get a1 plus a2 plus a3, but a1 plus a2 is b2. So b3 is b2 plus a3. So in general, if you want to find n plus 1, you put bn, the previous term, and add the next term of the first sequence e. Okay, so bn plus 1 is bn plus an plus 1. That is how it goes. So because this is already a1 plus a2, so this is the third term. Okay, so b2 is 1 minus half. For finding a3, put n is 3 here, you get minus 1 power 3, which is minus 1. This is 1 by 2 minus 1 by 3. So what I'm going to do is take this half outside here, pull this half outside, minus half. So group these three terms, 1 minus half plus 1 by 3. This 2 minus term become plus. B4, you find B3 plus A4, you get this expression, you can substitute from there. To save time, I'm just leaving that, okay, grouping terms. So what you do is pull, you see this minus half will cancel with plus half here. You get 1 minus half plus 1/3, plus times minus is minus, so you get minus 1/4. So in general, if you get some pattern here, see, for B1, you get 1 minus half. For B3, you get 1 minus half plus 1 by 3 minus 1 by 3. So this minus half is always a number that comes outside for odd index. For even index, it won't be so. For B2, you get 1 minus 1 by 2. For B4, you get 1 minus 1 by 2 plus 1 by 3 minus 1 by 4. So in general, Bn is 1 minus half plus 1/3 minus 1 by 4 up to minus 1 by n whenever n is even. For B4, it ends with 1 by 4. For B2, it ends with 1 by 2. So Bn, when n is even, it ends with 1 by n with a negative sign. See, I actually got this term by working up to B6 and B8. Only then I got this pattern. So this pattern is not visible immediately to me. So I worked out up to B7 or B8. Only then, to save the space here, I have cut short those steps here. You can work it out yourself when you find time. So Bn is this term minus half, the same term here, but minus half whenever n is odd. You can guess this pattern from this equation. See, most of the problems in analysis in general in any branch that you take works most of the cases with observing some pattern. And this is one such thing. If you notice this pattern, the answer is immediate. If you do not notice this pattern, this becomes horribly hard. In fact, I didn't notice this pattern for the first time when I did this, so I could not get this answer immediately. But after some time, refreshing my mind and comparing with other known results, I got this answer. Okay. Now, so supremum of B and C, which is larger here, this term, the first term is common to both the term because minus half is subtracted when n is odd here. Supremum of Bn is obtained only if n is even. This term is the supremum because we are subtracting half. So among these two quantities, because we are subtracting half, Bn when n is even will be correspond to supremum, and this will correspond to infimum. Okay. So supremum of Bn is limit of all these things, and this is actually log 2 because of the famous Leibniz formula. See, logarithmic series is log 1 plus x is, in fact I could have mentioned this in the next problem here. So this is log 1 plus x minus x square by 2 plus x cube by 3 minus x to the power of 4 by 4 and all those things. This works whenever x is strictly greater than 1 but less than or equal to 1. So if you put x as 1 here, you get log 2. Log 2 is log 2 with respect to base e. Okay, this 1 minus half plus 1/3 minus 1/4 plus 1/5. There's a typo error here. I'm sorry for that. 1 minus half plus 1 by 3 minus 1 by 4 plus 1 by 5 minus 1 by 6. That's an error. Log 2 is approximately 0.6931. Okay. So this is that series actually, log 2, and you see this is 0.6931 is strictly greater than half, which is 0.5. So the answer is second option. Supremum of Bn is greater than half because this is 0.6. If you take infimum, because the other options are given to infimum, so this can't be the case because supremum is greater than half, so limit cannot be equal to it. Because for a convergent sequence, if a sequence is convergent, then the limit value will be equal to the infimum value as well as the supremum value. Because supremum of Bn turns out to be log 2, if Bn is convergent, then what happens is limit of Bn is also the same number, so it is not 0. So this is not correct. Suppose if you take infimum of B, infimum corresponds to case when Bn when n is odd. So if I take that, the first term is same series as the first case for supremum. So this is log 2 minus half. Log 2 is 0.6931 minus half is 0.1931. That is only positive. So it is greater than 0, but it is given less than half. So that is also not correct. So this is incorrect answer. This is also incorrect answer. So we are left with only one correct option here, namely the second option. And this is straightforward problem, not much involved here. See, root of n plus 1 minus square root of n, multiplying and dividing by the corresponding conjugate of the radical signs, by namely minus with plus here. The numerator becomes 1, denominator is this, and this is less than, strictly less than, because root of n plus 1 is strictly less than 1, root of n plus 1 is greater than root n, therefore 1 by root of n plus 1 is strictly less than 1 by root of n. Using that fact, this value is less than 1 by 2 root n, and that is less than 1 by root n. So the answer is the second option. There's nothing to bother much more than this actually. So if you know this is correct and this is incorrect, this is incorrect. In fact, this is a single option question. So if it is less than 1 by root n, it cannot be more than 1 by root n. But see, 1 by root n, because n is a natural number, when n is very large, this goes to 0. So it's almost this approaches to 0, so it cannot be more than 1 or more than 2. Okay, so the answer is the second option. Which of the following is true? Summation n 1 to infinity minus 1 power n by n does not converge. In fact, it does converge. For this particular problem here, I have given this question here. Log 1 plus I have already told you. So this is Leibniz series. There's an error here. Please forgive me. 1 minus half plus 1 by third plus minus 1/4 plus 1/5. This is plus and this is minus. Plus 1 by 5 minus 1 by 6 and all those things. That approaches to log 2. Okay. So this is the first result. Using that, you can see that this is minus log 2. This answer is minus log 2. Because if you put n as 1, you get minus 1 plus half minus 1 by 3. The terms are exactly negative of this term, this series. And if this series converges to log 2, this will converge to minus log 2. So that will converge. So then this is incorrect. Summation 1 by n is a harmonic series that is divergent. It's a very famous result in series of real numbers. Summation 1 by n is called harmonic series. But I'll give a more general idea for tackling a general problem in future. If this is called p test, that is, if you take summation 1 by n power p, then this series will be convergent if this number p is more than 1. So for example, summation 1 by n square converges, summation 1 by n cube converges, summation 1 by n power 4 converges, summation 1 by n root n. See, if you take n root n, then it is n power 3 by 2. 3 by 2 is more than 1. So that is also convergent, but never tells to what number it does converge. But you can be sure enough that 1 by n power p, summation 1 by n power p, whenever p is more than 1, is convergent. Whereas if p is less than or equal to 1, that is divergent. So this is a very famous and important result that you have to remember, like the Euler formula that I told for sequence of real numbers, Eulerian limit, that in the previous class. Okay, so for p test, because I know that this is divergent whenever p is less than or equal to 1, this is divergent, because if you put p is 1 here, you get summation 1 by n. In fact, 1 by root n and 1 by n power any number which is less than 1 or equal to 1 is divergent. So that makes this divergent. There's a separate proof also that you have done in your BSc class. That proof was given by Nicholson Orr. This Orr's proof. Okay, you take subsequence like sequence of partial sums of the form S1, S2, S4, S8, and all those things. You show that that is not bounded and that goes to infinity. Therefore, this series also does not converge. Okay, so converges is the wrong statement. So this converges, but it is given does not converge, that is wrong. This diverges, but it is given convergent, that is incorrect statement. And both the series here are same series, but I have to decide which among them is correct. Summation m1 to infinity, n1 to infinity. So first I put the value of n here, keep this m as it is, put the value of n 1, 2, 3, 4. So m plus 1 whole square, m plus 2 whole square, m plus 3 whole square, and so on. Now take the summation to each term. Summation of this plus summation of this plus summation of this. Take the summation to each term, and then now substitute for this particular term. Put m is 1, you get 1 by 2 square plus 1 by 3 square plus 1 by 4 square and all. And if you put m is 1 here, you get 1 by 3 square, 1 by 4 square, 1 by 5 square, and all those things. If you put m is 1 here, you get 1 by 4 square, 1 by 5 square, and all those things. What you do is, if you see, look at the previous step here, there's only one by 2 square term, but there are two 1 by 3 square terms, one coming here and one coming here, and there's no 1 by 3 square term beyond that, because you see this first term itself begins with 1 by 4 square. So there are only two 1 by 3 square terms, so group it. There are three 1 by 4 square terms, 1 by 4 square here, 1 by 4 square here, and 1 by 4 square. There cannot be 1 by 4 square here, because the beginning term is 1 by 5 square here. So only three 1 by 4 square and four 1 by 5 square. Until this pattern continues on and on. So if you club this, 2 square 1, 3 square 2, 4 square 3, 5 square 4. So n plus 1 square n, the numerator. And you see there's an easy method to guess this. This numerator degree is 1, denominator degree is 2. So 1, 2, if you divide n by n square, this order is almost equal to n square. Listen, this order is almost equal to n square. If you divide n by n square, you get 1 by n. And I know that summation 1 by n diverges according to p test. Harmonic series diverges. Okay, therefore this answer is infinity. You can also use comparison test by taking 1 by n, bn as 1 by n, taking this as n and compare, and then do that. But anyway, this is a very easy way to guess this is compare the numerator and denominator. Okay, and then see, suppose if the denominator is of the form say n plus 1 whole cube, then this should have been convergent. Please listen. Instead of whole square, if I could have gotten whole cube here, this is not the case here, but if in the problem, if I reduce like n by n plus 1 whole cube, then the answer will be convergent, because there the numerator is n, which is degree 1, denominator will be of 3. If you cancel 1 with 3, 2 power will remain. Summation 1 by n square will converge because of p test. So because after cancelling 1 by n remains, summation 1 by n diverges according to p test. Therefore this is divergent. See, most often people will get confused because of double summation. The moment they see square, they choose this option, converges, but that deceives the answer here, because this double summation, this power will get cancelled out, so you get the divergent case but not the convergent case. So this double summation problem is very interesting and important. So this is given just for deceiving your common sense. Most students will write convergent because they know 1 by n square is convergent. Therefore, they see that because both the summation, both the terms are given, there's a square. Therefore, we p test, that is p test only for single summation. But the question is given for double summation, so you have to be very careful in doing this. Okay, and these are all given for deceiving you. Okay, so maybe I'll to the maximum possible, I'll finish in time. Okay, which of the following sets is countable? The set of all functions from Q to Q. See, I will just give glimpse of what I'm going to trying to say here. The cardinality of natural numbers is n naught. Okay, I'm taking cardinality of real numbers is C for continuum. The term C is for continuum. See, if the cardinality of a set goes up to set of natural numbers, which is n naught. See, n is natural number here. You know that set of rational numbers is also countable. So mod q is also equal to mod n. So the magnitude of any countable set is n naught, and magnitude of any uncountable set is c. So this is how we have to think about this. With this condition, we have this formulas. Okay, this you can note it down. The countable condition, countable set cardinality is less than the uncountable set cardinality. N naught is less than c, whereas 2 power n naught is c. C times c is c. So if you multiply a uncountable set taking cross product, so r cross r is r square. So if r is uncountable, r square is also uncountable. So similarly, like that, n naught power n naught, the countable set cardinality, power countable set cardinality is uncountable, and the uncountable set cardinality to the power countable set cardinality is uncountable. So these are all some nice relations that you can note down. And the number of functions that exist from A to B, number of functions that exist from between two sets A to B is number of elements in B to the power of number of elements in B. This is another nice formula, counting number of functions that can exist between two sets A and B. Now, using this ideas, I can answer these questions very quickly. You can just note it down. Set of all functions from Q to Q. Cardinality of Q is n naught, because cardinality of any countable set is n naught. So the number of functions that can exist from Q to Q is n naught power n naught, because A is Q, B is Q. So n naught power n naught, and you see n naught power n naught is c. So c is uncountable, but you are asked to pick only countable set. So this number of functions here is not countable, it's uncountable according to this equation here, because it corresponds to form n naught power n naught. Set of all functions from q to 0 power 0 comma 1, not interval, just set with two elements. So according to this formula, A is q, which is, cardinality of q is n naught, and this set cardinality is 2, modulus of b is 2. So the number of functions that can exist is 2 to the power n naught. 2 to the power n naught is c, therefore that is uncountable. Okay. And if you take this example, set of all subsets of n, set of all subsets of n is n naught power n naught, and that is also uncountable. Therefore, that is uncountable. You can think about this later. Because of need of time, I'm just a little bit rushing, but the justification is given through this equation, so you can just verify them. So only one option should be correct. I showed that all these sets are uncountable, therefore this has to be countable. In fact, this is countable set because we assume A as set of just A1, A2 up to A and small a1, small a2, A2 up to small an. You can have at the most n factorial functions that you can define using this condition. So any finite set, because it vanishes outside a finite set, there can be at the most 2 to the power n factorial functions, which is a finite set, therefore that is countable. So the third option is the correct option. You can just check it out with what I said later on. Okay. Now let A and B, this is multi-option type, but I found that in recent paper, even in multi-option question, there is only one correct option. That surprises me. Okay. Let A and n want infinity be a bounded sequence of real numbers, then every subsequence of A n is convergent, and all those answers are given. Now, if I take bound, because it's bounded, I'm taking sine 1 by n. You know, sine theta is always a number between -1 to +1. So this sequence is bounded sequence of real numbers. Every subsequence is not convergent because I can choose odd subsequence, and even this, in fact, limit of sine 1 by n does not exist, and limit of sine a to n, limit of a to n, the odd term subsequence is not convergent. Therefore, the first option is not correct. Every subsequent may not be convergent. In particular subsequence may be convergent. In fact, this answer is correct. I can choose infinitely many subsequents which are convergent, because the idea is this: if you give me half, I can choose values of 1 by n for which sine theta is half. So I will fix the value of half here, half here, half here. I can choose that only that values of 1 by n for which a n takes half, and therefore that will be a countable. That will be convergent because that works only for certain values, and you know the answer is always half, and half, half, half is a constant sequence, so that is a convergent sequence. In fact, I can choose this works for not only for half but for any number between -1 to +1. For example, if you give me 1, I can choose, so you know that sine pi by 2 is 1, sine 5 pi by 2 is 1, sine 9 pi by 2 is 1, and all those things. So every add 2 pi to pi by 2, for every addition of 2 pi you get 1. So I can choose 1 by n conveniently such that an is always 1 for such n, and therefore that particular subsequence is convergent. This similarly for 1, I can take half, I can take 1 by root 2, I can take any number between -1 to +1. So there are, because there are infinitely many numbers between -1 to +1, there are infinitely many subsequences which are convergent. If it works for infinitely many subsequences, then it automatically it works also a particular subsequence. There is a subsequence. You can always choose a particular subsequence from this collection. Therefore, the answer is option 3 and 4. First is not correct, as I told you, because a to n is not convergent, and there's exactly one subsequence. In fact, we told that there are infinitely many subsequences, so this is incorrect. Okay, so the answers are 3 and 4. For every natural number n greater than or equal to 1, let a n be defined as n by 10 to the power of greatest integer function of log n. Okay, smallest integer greater than or equal to x. That's called floor function. Some book may call it as floor function or greatest integer function, whatever you call it. So what I'm going to do is, because I want to find limit of n, n should be quite large here. Okay, I'm choosing n to be of the form. See, any number n lies between consecutive powers of 10, isn't it? Supposing if n is a 3-digit number, it lies between 10 square and 10 cube. If n is a 4-digit number, it lies between 10 cube and 10 power 4. So you see, any number of any particular digit will lie between consecutive powers of 10, like 10 power k and 10 power k plus 1. And greatest integer function, for those who already know, it's quite easy. If you substitute 10 power k here, because it's a logarithmic to the base 10, k comes down, you get log 10 to the base 10, you get k. So the answer is k for this choice of n. But n should be of the form, see, this r, which is some number here, will get, I take r to be maybe between 0 to 1. In that case, I get the answer as k. R is just a fractional part of n. Okay, so you see, an for this choice of n is 10 power k plus r by 10 power log n. The greatest integer function is k, so 10 power k. If you split this, you get 10 power k plus r by 10 power k. As limit n tends to infinity, k also tends to infinity. Okay, because n is greater than k, 10 power k. So if n is large, k is also very large. Okay, so if you divide, you get 1 plus r by 10 power k. R 1 by 10 power k, as k is large, goes to 0. So whatever r might be, that goes to 0. Okay, so you get the answer as 1 upon dividing this. So the answer is limit of an is 1 for this particular an. If limit of an is 1, limit of supremum of an is also 1, because if limit exists, infimum value, supremum value will always be equal. They are all equal. The answer is just fourth option. The other option will not be equal, because as I told you, because the limit of an is 1, limit supremum of an is also 1, limit infimum of an is also 1. So this is incorrect, this is incorrect, this is also incorrect. Only the correct option is the fourth option. Though it is given in part C, this has only one option. So you have to be very careful in doing this. This is straightforward question, -1 power m by m. As I told, if you put m, but it is starting only from m greater than or equal to n. So this is less than or equal to this sum, and this sum we already saw here in this problem. This is the same sum. This is minus ln 2. That is convergent because of this series. Okay. So this sum is beginning only from the nth term, but here we begin from the first term. So this is less than or equal to this. This is convergent to minus ln 2. Therefore, this is also convergent. In fact, this is again a question multi-option type, but the answer corresponds to only one option, namely the fourth option, convergent. Not anything else. It's not absolutely convergent, because if you take modulus here, you get 1 by m, that is a harmonic series. Harmonic series diverges. Okay, so it's not absolutely convergent. It is only conditionally convergent. And this is, I think, my last problem. I think I can finish in time. uh, for any alpha which is a real number, greatest integer of alpha denotes the greatest integer smaller less than or equal to alpha. We define a function d from r cross r to non-negative real numbers, that is 0 to infinity, by, see, d of xy is greatest integer of modulus of x minus y. See, modulus of x minus y is a non-negative value. You take greatest integer of that value. See, greatest integer function, for those who do not know, greatest integer of 1.5 is 1. So you have to choose numbers less than or equal to 1.5 and integers less than or equal to 1.5 and pick the greatest among them. So the integers less than or equal to 1.5 is are 1, 0, minus 1, minus 2, and all those things. All those integers less than or equal to 1.5 are 1, 0, minus 1, minus 2, and the greatest among them is clearly 1. So for positive real number of the form, say a point, b1, b2, b3, etc., you truncate the decimal part. The answer is just the integer part. Like if you want to find greatest integer function of pi is 3.14 approximately. So you truncate the 0.14 part, the fractional part, you get the integer part 3. So if you know this you can do this problem, okay? Because my range is non-negative. Okay. So for those who do not know about greatest integer function, please look at them carefully. Because it's very, very important. There are two functions that are very important and critical in doing net exam or some other exam problems, GATE exam, for example. Most often they are usually very repeatedly asked. One is modulo function, mod x. The other one is greatest integer function of x. These two functions are very, very important. Most of the questions will be concentrated using these examples. Okay. The greatest integer function is a function which has countably many discontinuities. In fact, discontinuities occur at integer points. So this, in fact, I showed the graph of greatest integer function in the previous class. Okay. So d of xy is 0 if and only if x is equal to y. So this is actually one property of the metric. Metric d is non-negative. If in a metric space you define metric with 4 axioms. One of the axioms says that d is non-negative and d is 0 if and only if you have only equal points, x is equal to y. But you see, I am taking 2 points here, 0.2 and 0.5. They are clearly unequal. X is 0.2, y is 0.5. According to this function, d of 0.2 comma 0.5 is greatest integer function of modulus of 0.2 minus 0.5, which is 0.3. And by the example that I said, greatest integer of 0.3 is delete the fractional part, you get 0. So though x is not equal to y, distance between x and y is 0. Therefore, first option won't be correct. If first option is not correct, then the fourth option is, in fact, this is correct, because for being a metric, this is one of the property. For metric, for a function d to be a metric for a metric space, d is non-negative for any xy, and d is 0 if x is equal to y. Whenever x is not equal to y and d is 0, that kind of metric usually is called a pseudo metric. Okay, this kind of metric is usually called a pseudo metric. But and this will be satisfied. D of xy will be equal to d of yx, because if you put yx here, you get modulus of x minus y same as modulus of y minus x. So this will satisfy the symmetric property. This is one of the axiom of being a metric, but this axiom is not satisfied. The answer, fourth option, is one of the correct option. This is also the correct option, second option. First option is not correct because of this example. How about the third one? Third one is a little trickier. I choose x to be 0.5, y to be 3.5, z is 2. So the idea is choose y between the values of x and z. I mean, in particular, more than x and z, such that it's almost equidistant with x and z. Like, okay, so I mean, such that the distance between x and y is little larger. So in other words, z is equidistant between x and y. For example, distance between x and z is 1.5. Distance between y and z is also 1.5. So choose such examples. Choose y such that z is equidistant, midpoint of x and y. So you can always choose that kind of value. That will work here. So by choosing this values here, d of xy is distance between 0.5 and 3.5. If you subtract, you get modulus of 3. Modulus of minus 3, in fact, that is 3. Greatest integer function of 3 is 3. So d of xy is 3, the left hand side. If you take the right hand side, d of x comma z, this is 1.5, modulus of 1.5. Modulus of, you get greatest integer of 1.5 here. modulus of 0.5 minus 2 is 1.5, and the greatest integer of 1.5 is simply 1. So d of x comma z is 1. Similarly, this difference is 1.5. Taking greatest integer value, you get 1. So this is 1, this is 1, that adds up to 2. So if this property, namely the triangle inequality, is correct, then I should get 3 less than or equal to 2. That is clearly false. Okay, because 3 is strictly greater than 2. Therefore, this function d does not satisfy the third property also. The answer is second option. Which among the following are true? Only second and fourth are correct. So the answer is option 2 and option 4. First and third are incorrect. So I think I finished with this problem. I heard that 26th of November is the net exam for aspiring students who had applied. I wish every one of them to have a great crack at net. So as I told you, don't get tensed and don't get very quick. Don't get excited and enthusiastic more. You think more than twice to be, especially in questions like multi-option type and functions like mod x and all those things. You just think about more than twice before you conclude your answers. With this little careful observation and working with the basic principles and some beautiful ideas, you can say for cracking net exam, even if you do 50% of the problems correctly, that is enough for you to crack for most of the students. So you need not have to concentrate on doing everything correct. So whatever you do correctly, that is enough for you. So take care that whatever you do is correct. You leave away, don't concentrate or worry much about you do not know. But be sure enough about whatever you are doing, that is correct. So with this, I think I can conclude my class. I thank everyone who helped me in doing this. I hope these classes are useful. We will continue with some other classes in coming future days, and I hope to see you again in this platform. Thank you.
Thank you, sir. We wish to express our gratitude to our chief guest for being with us on this event. Your presence
So
and
I'm not
gentle
chief
words are
guest. I'm
source of
one of the
encouragement.
person here. Don't tell me chief guest, okay? I'm one of among you. Okay.
From this event, you are a chief guest, sir.
No. I'm just one among you. So
Okay.
good luck to everyone. We'll see you later.
Thank you, sir.
Thank you.
I would like to thank Professor R. Venkatramanan, Head PG and Research Department of Mathematics, for organizing the C4 workshop. Thank you so much, sir. I am very proud to inform about our next program, C4, Chase, Crack, Conquer, CSIR Net. This is a free online coaching for CSIR Net aspirants. Classes will be on every Saturday 6 p.m. to 8 p.m. and every Sundays 11 a.m. to 1 p.m. Our 11th session will be held tomorrow at 11 a.m. So next national level webinar titled Uniform Convergence presented by Dr. P.S. Srinivasan, Assistant Professor, Department of Mathematics, Bharathasan University, Tiruchirappalli, which will be held on 28th November at 10:30 a.m.